Okay, let's just jump right in. I want you to imagine something for a second. Picture traveling between two whole countries, but you never see the sky. You don't see the sea. Instead, you're just rocketing through this massive tunnel, dug deep beneath the seabed. You know, it sounds like something straight out of science fiction, right? But for millions of people, it's just a daily reality.
So, how do you do that? For centuries, that was the question between Britain and France. And the answer? Well, it finally arrived in 1994. It's the Channel Tunnel, an absolute marvel of engineering that didn't just connect them, it completely redefined how Europe travels and trades.
So in this explainer, we're going to dig into how this absolutely colossal project was even built. We'll look at the insane challenges the engineers had to face, and of course, the massive impact it's had on the world ever since.
You know, you might think this tunnel idea is a pretty modern thing, but actually, nope. The dream of a tunnel, that goes all the way back to the 19th century. It was this grand, ambitious vision to finally create a solid link for trade, for travel, and just for connecting people between the UK and the rest of Europe.
But man, turning that dream into a reality, that took generations. You have these first wild proposals back in the 1800s, and then a whole lot of waiting. It wasn't until 1985 that the serious work, the modern designs, the geological surveys finally got going. And things moved fast from there. Construction kicked off in '88, and by 1994, boom, the Channel Tunnel was officially open for business.
Okay, let's really get into the engineering here, because the challenge they faced was just immense. We're not talking about just any tunnel. This was going to be the world's longest underwater tunnel. We're talking about digging down 75 meters below the seabed, where the water pressure is just absolutely crushing.
And this is where it gets really fascinating. The entire success of this project, it all came down to geology. It was like a giant Goldilocks problem. The engineers had to thread this incredibly precise needle. If they dug too high, they'd hit fractured chalk full of water, a total disaster. Too low, and they'd be in this unstable gunk called gult clay. But the geologists found the perfect sweet spot, this one single layer of chalk that was strong, mostly waterproof, and didn't have a bunch of hard flint to break their machines. Sticking to that one layer, that was the decision that made the whole thing work. So you might be thinking, they just built one big tube, right? Wrong. They built 3 of them, side by side. And this ingenious 3-tunnel design wasn't just about making things run smoothly. It was the absolute heart of the tunnel's safety system.
And here's how that setup works. You've got your 2 big tunnels for the trains, one going from the UK to France, the other from France to the UK. But right in the middle, sandwiched between them, is a smaller service tunnel. And this little tunnel, it's the lifeline. It's a completely separate pressurized escape route for maintenance crews and, most importantly, for emergencies. It's totally isolated from anything that could go wrong in the main tunnels.
All right, so we've seen the engineering genius, but what about the money? The economic impact was just staggering. This marvel of engineering quickly became a massive economic engine. I mean, the tunnel didn't just connect 2 bits of land, it basically fused 2 economies together, completely transforming how the UK and Europe do business.
Just look at that number. Take a second to let it sink in. Over 91 billion pounds. That's how much trade passed through the tunnel in just 1 year, back in 2014. To put that in perspective, that's a full quarter, 25% of all trade between the UK and the EU. It's not just a tunnel, it's a vital economic artery.
So why are so many companies piling their goods onto these trains? Well, it's pretty clear, isn't it? For a whopping 90% of them, it boils down to one simple thing: speed. Getting things there faster is king. But right behind that is the fact that there are so many trains running, and you have the flexibility to just show up and go whenever you need to.
And this incredible speed and reliability, it wasn't just a nice little convenience. No, it enabled a whole revolution in how things are made. It's a strategy called just-in-time production. And what it means is that, say, a car factory in the UK can count on parts from Germany showing up with only a 15-minute window for delays. Just think about that for a second. Entire supply chains stretching across countries are running with the precision of a Swiss watch, and it's all possible because they can depend on this one tunnel.
But okay, it's not all about trucks and cargo. The tunnel totally changed things for regular people too. It basically created this new European Main Street, connecting Britain to the continent in a way that had huge knock-on effects for tourism, for jobs, and for how people live.
And of course, the Eurostar train is the icon of this whole revolution. Suddenly, you could get from the very center of London to the heart of Paris in just a bit over 2 hours. It's incredible.
In 2014 alone, 21 million people did just that. It made weekend getaways and quick business meetings not just possible, but easy. Easier than anyone had ever imagined.
And, of course, all that economic activity, all that movement, it translates directly into jobs for real people. We're talking about an estimated 220,000 jobs in the UK alone, all supported by the exports that travel through that tunnel. That's people in manufacturing, in electronics, all over the country.
But a structure's true test isn't just about how it works on a good day. It's about what happens when things go horribly wrong. The tunnel's real legacy was forged in fire. And the story of the 1996 fire, well, it wasn't a story of failure. It was the ultimate proof that the engineering worked. So here's the scene. It's November 18th, 1996. Deep inside the tunnel, a fire erupts on a truck that's on a freight train. The train grinds to a halt almost 19 kilometers from the French coast, deep under the sea. I mean, the situation was about as dangerous as it gets.
But check out how the response unfolded. The first smoke alarm goes off at 9:49 p.m. By 9:57, just 8 minutes later, the train makes a controlled stop right next to an escape passage. And by 10:25 p.m., every single person was safely evacuated into that service tunnel. That's less than half an hour to get everyone to safety. Just a remarkable feat of coordination.
So how on earth did they pull that off? Well, remember those key design features we talked about? They worked together in perfect harmony. Step 1. Everyone walked through a cross passage into the totally separate smoke-free service tunnel. Step 2. That service tunnel was being pumped full of fresh air, creating a higher pressure that literally blocked smoke from getting in. And Step 3. Giant fans were actually controlling which way the smoke went in the main tunnel, pushing it away from the escape route. Brilliant.
And the result of all that planning? Well, despite a fire that was so intense it reached 1,000 degrees Celsius and did serious damage to the tunnel, every single person got out safely. 0 fatalities. The engineering worked. It worked exactly as designed, under the absolute worst conditions imaginable.
So what's the big takeaway here? The Channel Tunnel is so much more than just a tube of concrete and steel under the ocean. It's really the culmination of a dream that was centuries in the making. It's a powerful testament to what we can achieve when nations decide to work together, and it's an absolute masterclass in brilliant, life-saving engineering.
You know, the Chunnel really proved that we can build bridges, even under the sea, that we can conquer these incredible physical barriers to bring people closer. And that really just leaves us with one final thought, doesn't it? What barrier are we going to conquer next?